ever felt totally lost in the alphabet soup of computer chips, CPU, GPU, NPU, you are definitely not alone. So today, we're going to break it all down and figure out what the future of computing actually looks like.
Right? If you've looked at any tech specs lately, you've seen this mess of letters and probably thought, what is going on here? Is my CPU obsolete now? It's a totally fair question. And the answer, well, it's probably not what you're thinking.
See, here's the thing. It's not a competition. It's not about one chip being the best. It's all about building a specialized team. Think of it like a crew of experts, where every single one has a totally unique talent. So, let's meet them.
Okay, first up on the team, the OG, the veteran, the brain of the whole operation, the Central Processing Unit, or CPU. So let's call our CPU the professor. This is your brilliant PhD-level generalist. It can handle incredibly complex, logic-heavy problems, but it really prefers to focus on one difficult thing at a time, one after another.
And there's a good reason it works this way. The CPU has been the heart of computing since its basic design was laid out, get this, all the way back in 1945. Yeah, seriously. It was built from the ground up to handle tasks in a series, running your operating system, your apps, making all the big decisions. It's the undisputed boss.
But the professor is way too busy with advanced calculus to, say, paint a masterpiece. So if it's handling all the core logic, who's in charge of the millions of pixels that actually make up the image on your screen? And that is where we bring in our next specialist, the Graphics Processing Unit, the GPU.
We're going to call the GPU the army of elementary students. Just picture thousands of them. Now, each individual one isn't a genius, but they are fantastic at doing one simple repetitive task over and over again. And when they all work together at the same time, in parallel, they can knock out a massive job, like drawing a complex 3D world unbelievably fast.
And that, my friends, is called parallel processing. And the GPU is the absolute master. It's the reason your video games look so incredible and your video editing is buttery smooth. But here's where it gets really interesting. That exact same power, that parallel processing, turns out to be perfect for training huge AI models. That's made the GPU an unexpected superstar in the world of AI.
So, okay, we've got our thinker, the professor, and our massive workforce, the army. But modern AI isn't just about raw math or simple repetitive work. It's about spotting weird, subtle patterns. It's almost like intuition. So who on the team handles that?
For that, we need to bring in the new kid on the block, the Neural Processing Unit, or NPU. Sometimes you'll also see it called a TPU, a Tensor Processing Unit. Whatever you call it, this is the purpose-built brain for AI.
Let's call the NPU the right brain. It's not a general mathematician like the CPU, or a brute force army like the GPU. Nope. This one's more of an artist, a pattern finder. It's designed from the silicon up to be incredible at one specific type of math. Matrix multiplication, which is basically the native language that neural networks use to learn and think.
And this is where you can really see its advantage. When you put an NPU head-to-head with a GPU on AI tasks, especially for stuff like running a large language model right there on your device, which we call inference, the numbers are just staggering. We're talking up to 60% faster. But honestly, the real game changer is the power efficiency.
And just to put a finer point on it, benchmarks from the Korea Advanced Institute of Science and Technology showed an NPU design getting those faster speeds while using 44% less power than a modern GPU. Just think for a second what that means for your phone's battery life or for the insane energy costs of a giant data center. It's a massive, massive deal.
Okay, so our team is pretty stacked. We have a professor, an army, and a specialized AI brain. But what happens when we run into a problem that's just fundamentally beyond what classical computers can even handle? Problems with a ridiculous number of variables? For that, we have to go to the absolute bleeding edge of computing and meet the final member of our team, the Quantum Processing Unit, or QPU. We're going to call this one the Wizard. The Wizard, it just doesn't play by the normal rules of ones and zeros. It uses these wild quantum principles like superposition, where a qubit can be both a 1 and a 0 at the exact same time. This lets it explore millions of possibilities all at once. It's not just about being faster, it's about taking a completely different, almost magical path to find the solution.
Now, don't get me wrong, we are not going to see a QPU in our phones tomorrow, but its potential is absolutely world-changing. I mean, from designing new medicines and materials to creating a whole new generation of AI and cracking financial models we can't solve today, the QPU is set to tackle some of humanity's biggest challenges.
So after meeting our entire team of specialists, what's the final verdict? Who wins the processor wars?
Well, just like this quote from Huawei's Big Data Center 2030 report says, the future isn't about a single winner. It's about collaboration. It's about all these different specialized devices learning to work together.
And you know what? There's a fancy industry term for this: heterogeneous computing. It's basically the official recognition that the whole one-size-fits-all approach is over. The future is about using the absolute best tool, the right specialist, for each specific part of the job.
So the bottom line is this: we're moving away from that old model where the CPU was expected to do everything. We are now firmly in the era of the specialist team, where the CPU is the manager, delegating tasks to the GPU, the NPU, and yeah, one day, even the QPU, to get the job done faster and way more efficiently than ever before.
And this whole team model is going to be essential. With predictions showing that the demand for computing power is going to grow 100-fold by 2030, our current team is just the beginning. The real question is, what kind of new problems are going to emerge, and what new specialists will we need to invent to solve them?